Hello, and thank you for coming back once again to listen to one more of these videos. This time we're going to see how to estimate the integral of f of x from 0 to 10 using only the data that's given to us. So we don't know the equation for the function, we don't have a graph that we can calculate area with, we only have a table of data. So we have some sample data, we can't get the actual integral, but we can estimate it. So we're going to use trapezoids, okay, and I guess I should have added that here. So we're using trapezoids because in a few moments, or actually in the next video, I'm going to do it in a few moments, but in the next video we're going to use Riemann sums, a different method. So if we're using trapezoids, then what we do is we will create a new table. And in that table we're going to have 4 columns. We'll have interval, we'll have width, then we're going to have something that I'm calling h1 and h2, and we're going to add those two together. We'll see how we generate those in a moment. And then at the end, what we're going to have is we're going to have the area, which is equal to 1/2. The area of a trapezoid is 1/2 the width by the sum of the heights. Okay? So that's our table that we're going to produce. Okay, the interval. This is going to be the x's, and the first interval is going to go from x equals 0 to x equals 1. So from 0 to 1. Now, a word of warning, I had somebody do this one time when I was starting off this section, and I didn't use an arrow there from the 0 to 1, I just did 0 stroke 1. And one of my students thought it was a subtraction, and they were getting all sorts of problems because they were thinking of -1 as an interval. Please don't do that. So from 0 to 1, that's an interval of 1. Okay, that's a width of 1. Okay, from 1 to 0 or 0 to 1. h1 and h2 just means take the f of x reading, so the intervals are going to be the x's, the h1 and h2 are going to be the f of x's. Okay, so h1 and h2 means what is the value of the function at either end of this interval. So at 0 the height is 12, and at 1 the height is 16. Okay, so you add those two, 12 and 16 gives you 28. Okay, now here you have 1/2 of 1 times 28, so that's going to be 14. Then we went from 0 to 1, we now go from 1 to 3, and that is an interval, that has an interval width of 2, from 1 to 3 is 2. So you're going to add up the heights at 1 and at 13, when x is 1 and when x is 13. So that's going to be 16 plus 19. And 16 plus 19 is 35. So this time we're going to have half, the width is 2 this time. Half times 2 times 35 is simply going to be 35. Okay, so 0 to 1, 1 to 3, the next one's going to be 3 to 6. Well, the width there is 3. Okay, just if you're confused, it's just subtraction. 1 take away 0, 3 take away 1, 6 take away 3. That's all it is. h1 and h2 in this case, 3 and 6, that's going to be 19 plus 15, which is equal to 34. So this time the area is going to be 1/2 of 3 times 34. So 17 times 3 is 51. Sorry, did I say 17? I should have said 17, but that should have been a 4 there. Okay. So we've got 3 to 6. Now 6 to 8. And I'll just go through this a little bit faster. We're going to do 8 to 10 as well. So 6 to 8 is 2, and 8 to 10 is 2. 6 to 8, that's 15 plus 11. So that's 26. And here we're going to have 11 plus 3 is equal to 14. In this case it's going to be 1/2. The width is 2 by 26, which is simply equal to 26. And the last one, 1/2, the width is 2 again, times 14, which again is simply equal to 14. Now, we've completed the entire table. The last thing to do is add up these areas, because what we've done is we've calculated the areas of individual trapezoids, and if we add them all together, that gives you 140. Okay, and that is actually your estimate. So the integral from 0 to 10 f of x dx estimated by trapezoids in this case is going to be equal to, or approximately equal to, 140. Okay, thank you. Simple enough.